All right. We've got 2.5, 19 through 31. All right. So homework 2.5, 19 through 31. The biggest thing on this homework is I is equal to the square root of -1. Okay? This is just talking about complex numbers. Last year I had you in geometry. We talked about this for maybe a day when you were doing quadratic formulas. So now we're going to get into it a little bit more. This is where we're going to be doing upside down division a lot. And we're just reducing. Remember, this is the whole key, is that I is equal to the square root of a -1, the negative number. It's the only way we can deal with negative square roots. Okay? So to do that, it's really quite simple. Here you got 8 square roots of 4. Remember, if we want to take that square root of 4, I got to break it down. Remember that upside down division? I want to break it down by doing upside down division. The way I teach negative square roots is really simple. The first step, remember how we used to just take the first step was taking out 2s, 3s, 5s, 7s, all your primes, right? Okay? So we're still going to use that. 2, 3, 5s, 7s, and on and on and on, right? But the first thing we're going to use with imaginary numbers is I. So it's real simple. I'm going to take an I out, and that leaves me with 4. Okay? And then I'm going to take my 2 out, and that leaves me with 2. I'm going to take my 2 out, that leaves me with 1. When I get to 1, I'm done, right? And then I circle my pairs. Remember that part? You circle your pairs, and you trade 2 for 1. We all know that the square root of 4 is 2, right? Okay? But this is coming out, so it's 2, and then this is coming out, so it's I, and there's nothing left, right? Except for this part, which is 8. So what's 2i times 8? Yeah, it's 16i. And that's the answer for number 18. Now we don't have to do 18, but I wanted to show you a nice easy one first. Okay? Yes, sir.
So taking out the I takes it from a negative number to a positive.
That's right.
What is I?
I is the square root of -1. Whenever you use the letter I, everything goes into the imaginary realm. I'm going to explain that when we get down here. Okay? Let's explain it a little more when we get down to here. Okay? But for right now, we're just going to deal with I's. And we're going to deal with how to find them. Okay? So, how to find an I in here is the same thing for number 19. I'm going to start with just this, and then don't worry about the outside number. Right? The square root of -90. I always take that -90, right? And then I start messing with it. Okay, I'm going to take out an I, so that brings me down to 90. And then what am I going to take out? What's the first prime that goes into 90?
10.
No. 10 is not a prime. Again, 2, 3, 5, 7. Start with the first number, which is 2. Okay? It's an even number. 2 goes into it 45 times. Right? And then what's our trick? Does 3 go into 45? And how do we know it does? The reason why we use 2's is really simple. The trick is, if it's even, 2 goes into it. Okay? This is all 4th grade stuff, right? 3rd grade. If it's even, 2 goes into it. If you add the numbers up, 4 plus 5 is 9. 3 goes into it. Okay? If you can add the numbers up and it's a number 3 goes into, then 3 goes into that original number. Kind of like, you can make anything up. 2, 8, what do I have to add to the end of this one to make it divisible by 3? Well, anything that adds to 10, that's divisible by 3. So 12 would be 2, right? So that's divisible by 3. 2, 8, what else you add to 10 that's divisible by 3? 15, right? So 2, 8, 5 is divisible by 3, and so forth, okay? These are all divisible by 3. So I know that 45 is because 3 goes into 9. So now I go to my 3 because I know 2 doesn't because it's not even, correct? So 3 goes into 45 15 times, okay? And then does 3 go into 15? Well, 1 plus 5 is 6, so yeah, it does. It actually goes into there 5 times. Well, does 3 go into 5? No, but 5 does, right? Okay, and when you get to 1, you're done, right? When you get to 1, you're done. Now the whole key here is trading out, because this is a square root. Remember, a square root has a hidden 2 in here. We're trading out 2 inside the box for 1 outside the box. So I just look for pairs. I see a pair of 3s here. So that's going to come outside the box. Whatever isn't circled, okay? Whatever isn't circled, and the I is going to come outside the box, right? And whatever isn't circled goes inside the box. What's not circled? 2 and 5. What is 2 times 5? 10. So what we have here is 3i square root 10. But remember, we started with this negative 1/3 out there, right? So now I got to take negative 1/3 times 3i. So what is a third of 3? 1. What's a negative third of 3? Negative 1. So I've got negative I square root 10. And that is how you deal with i's. Okay? Should I do that on the sideboard here so it's not all in the confusing words behind it kind of thing? Do that one more time. Okay? So, again, 19. That was 11. 19 gives me negative 1/3 square root negative 90, right? And then I'm going to break down the negative 90. I just worry about what's in the box first. And I break that down by taking out an I. The I comes out first. No matter what, that's coming out. Then I'm left with 90. Okay? Now I just take 90 and break it down. 2, 45. 3, 15. 3, 5. 5, 1. When I get to 1, I'm done. I'm going to circle my pairs. I can circle my I too if I want, because I comes out automatically. Okay? The 3 comes first, then the I, and then whatever's left stays in the box. 2 and 5. So what I'm left with is 3i square root 10. And then I bring down this, right? What was outside? So negative 1/3. What is negative 1/3 of a 3? We came up with negative 1. So negative I square root 10. Okay? And that's 19. Better? Okay? So So number 21. Come over here. Okay. Number 21 is square root of negative 50. Okay? This just goes right back to how we do the square roots of 50, right? Except it has an I in it. No big deal. I'm just going to pull out an I. Okay? That's going to leave me with the 50. And now everything else is the same. 2 goes into there 25 times. 5 goes into there 5 times. 5 goes into there once. When you get to 1, you're done. Right? Okay? Circle your pairs. This is my pair. So I can pull out a 5. I can pull out an I. Whatever's left stays in the box. That's a 2. And then if I have anything multiplying against it, I multiply it. It doesn't, so I'm done. 5i square root 2. Okay? If I want to look at 23, all right? So this takes us to the next level. 23 is 5i squared equals 80. No, negative 80. Okay? Now, with this, to solve, we want to first simplify, right? Do the opposite. Divide by 5, divide by 5. Okay? I was talking to Hal downstairs. I do the PIMDOS and the SAD-MAP, right? And he likes to do this visual. He does PIMDOS and SAD-MAP, but then he does this visual thing where he does this ladder, where you have parentheses, right? And then you have exponents. What he does is he just working with the students. He's doing square roots and squares, right? So you're going to have a square, and you're going to have a square root, right? So these are the opposites of each other, right? And then the next opposites are going to be times and division. And the next opposites are going to be plus and minus, right? And so you can look at this and you can work up the ladder, work down the ladder. Down the ladder means simplification or PIMDOS, right? Up the ladder means you're solving. So you're going to start with addition, subtraction, can't add, hit division, multiplication. We're multiplying, so we're going to divide, okay? Kind of thing. I liked it, so I'm going to start incorporating that a little bit, especially with Algebra 1 students. And so if you're having trouble with your PIMDOS and your SAD-MAP, this might be a way of getting better with it. It's right back down to x squared equals, and then 5 goes into 80. Well, 5 goes into 8 once, right? With 3 left over. And then 5 goes into 30. See how I do the short division? 5 goes into 30 6 times. So we got negative 16. Okay? Then we're going to get rid of a square, we got to do the opposite. We're going to square root it. Right? And for you guys, it doesn't matter what it is. X to the A, the opposite of it is square root, or the A root. Right? If it's x to the 5, the opposite of it is the 5th root. If it's x to the 7th, the opposite of it is the 7th root. Does that make sense? So, this is where we're getting to. This is what we're going to be doing this year. It's getting into the bigger roots, more fractional exponents. In this case, I want to square root both sides, but remember, you have to have that plus minus out there. Whenever you square root, there's 2 possibilities. There's a plus and there's a minus. Okay? This gets rid of the square, so you get x. Now I've got to take this square root of 16 and break it down. I got I. That leaves me 16. I got 2. That leaves me 8. I got 2 that leaves me 4. I got 2 that leaves me 2. I got 2 that leaves me 1. Right? And so then I take the pairs. And I get I. And I get 2. And I get 2. And so I get 4I. And so x is equal to 4I.